Welcome to this introduction to Brüel Kjær's Source Path Contribution featuring Timedomain SPC and SPC Time Insight. Source Path Contribution is based upon the Source Path Receiver model, and it tells you where the noise is coming from, how it gets from the source to the receiver. It can tell you if it's the source that's too loud, or if it's a path that transmits noise too easily. It can help you understand how to fix the noise problem, either by changing the source level or the path, and what will happen to the sound when you make a design change. Source path contribution techniques can be applied to sound or vibration for any product. Source path contribution techniques have traditionally been performed in the frequency domain. Now, with Brüel Kjær Time SPC, all the same calculations can be performed in the time domain. With Timedomain SPC, you can now listen to your noise paths and results. You can perform SPC analysis on transient events, which was never before possible with frequency domain techniques. You can play back and modify your results, set target levels, troubleshoot, and truly understand your data in the interactive SPC Time Insight software. In Timedomain SPC, you can use the same proven methods that have traditionally been used in frequency domain SPC analysis, but with true time domain calculation and results. You can process any type of signal with Timedomain SPC, including stationary or steady state signals, non-stationary, run-up, run-down type signals, or transient signals. Again, transient signals cannot be easily processed with frequency domain techniques and require time SPC processing. For airborne and structure-borne matrix inversion techniques, the powerful Timedomain SPC matrix validation tool assists in viewing and handling the matrix and in processing the Timedomain SPC data. As an example, I'll demonstrate how Timedomain SPC can be used to analyze both airborne and structure-borne paths on a Class 8 heavy truck with a diesel engine. In this example, there are 6 acoustic sources and paths, including the front, top, right and left sides, bottom and rear of the engine. There are 6 structure-borne connection points to the cab that are characterized, each in 3 directions, for a total of 18 paths. And the driver's right and left ear positions are used as receivers. SPC Time Insight is used for the playback, analysis, modification, and evaluation of your Time SPC results. You can play back the contributions either all together or as groups or individually. You can compare models side by side. You can modify your data on a path-by-path basis. This is especially useful for target setting and troubleshooting. And you can also view all the results in the frequency domain. Here's the SPC Time Insight software. And here I have all my contributions ready for playback. First thing I'm going to do is select a range for playback based on RPM. And then I'm going to play back all the contributions at once. Next, I'm going to play back just the structure-borne contributions from the front of the cab, and then from the rear of the cab, and then just the airborne contributions. I can also play back single contributions. I can synchronize different models or measurements based on RPM or time or other factors, which makes it very easy to do A/B comparisons and play things back to back. I can look at the data in the frequency domain simultaneous with playing it back. I can use narrowband or third octave analysis. I can look at this on a frequency axis or an order axis. I can also look at this as a waterfall, or a contour or a color map. I can also display each single contribution, the blue line, compared to the overall, the red line, along with its sensitivity function and source strength. I'm going to turn the sound off and then compare some of these contributions in the offline display. Here we have cursors on the offline display color map, and we have our overall measured data of the driver's ear over here, where we can identify an area of concern around 200 Hz. Here I've displayed contributions from the left cab mount X, Y, and Z, the right cab mount X, Y, and Z, and some from the rear also, which are less important. Here's our area around 200 Hz, and you can see that the front right cab mount X and Y are the main contributors to that. Here I'm going to add up just the X, Y, and Z from the right mount, and you can see that the right mount contributes virtually all the energy in that 200 Hz band. Now I'm going to switch over to a display that shows the source strength or force, the path sensitivity, and the contribution for the front right cab mounts X, Y, and Z directions. With the synchronized cursors, it's very easy to see where your peaks occur at. So here, around 200 Hertz, we can see that there's a very large peak around 200 Hertz in the Y direction and in the sensitivity of the Y direction. Now I'm going to go back to playing back the sound, and you can see here that peak at 200 Hertz. Now what I'm going to do is show the partial contributions of those, and for some of these it doesn't really contribute very much because those are the left side mounts. But when we get down to the right side, it definitely shows a big contribution to that peak, especially for the Y direction. Now I'm going to apply some filters to that. First I'm going to apply a notch filter. I'm going to define the center frequency just over 200 Hertz in the middle of that peak. I'm going to define the attenuation that I want, as well as the width of that filter. Now I can play that back and listen to and watch the difference when I turn that filter on and off. You can see a pretty significant difference just from filtering the Y direction. Another type of filter that you can apply is a user-defined FIR filter. Here you can literally draw in whatever filter shape that you want. Again, I'm going to play this back and turn it on and off. Here you can again see the big difference that it makes at 200 Hertz when you turn that filter on and off. Now it's not just the Y direction that's contributing here, it's also the X direction. So I'm going to copy that filter over and apply it to the X direction. Then I can turn the filters on and off for the X and Y direction together. And here you can see a huge difference in that peak at 200 Hertz. For further detailed analysis and reporting, the Timedomain SPC results work seamlessly with the Pulse Reflex software. Timedomain SPC can be used in conjunction with the NVH Vehicle Simulator to create fully interactive, drivable vehicle models based upon source, path, and contribution data. Time SPC can also be used with our indoor pass-by software to understand the sources and contributions to the overall pass-by level. Brüel Kjær Timedomain Source Path Contribution software enables you to listen to your noise paths and results, perform SPC on transient events, and playback, modify, set target levels, troubleshoot, and understand your data in the interactive SPC Time Insight.